Got a tissue that I wish you saw. Sarcastic Mr. Know-It-All. I'll close your eyes and I'll kiss you, 'cause with the birds I'll share.
Alright, check out that pretty awesome tattoo. We're going to have some last section of Chapter 9, Sectors and Segments. Going to throw a couple tattoos in there. Curiously enough, I'm the only algebra without a tattoo. I'm not going to name any names whose tattoo this is, but I think if you look back at previous videos, you may know who loves this guy and loves Toy Story. Let's get this rolling. So this is the end of Chapter 9, but don't worry, because Chapter 10, you're going to use this all the time. So it's going to keep sticking with you. Hopefully it's going well and you're digging it a little bit. Let's find sectors. When I think of sectors, what am I thinking about? Well, here's a formal definition right here. And that's true. It's the region bounded by an arc of the circle and the two radii of the arc's endpoint. So that's a very formal definition there. Basically, it's this piece right here. I think a piece of pizza. It's just like a slice of pizza. So if I have this, this is called sector, and I name it just like I would the angle. This is sector R. Whoa, RPS. Hey, let's see if I can write that correctly. RPS. So just like you're naming the central angle, I'm naming that sector or that slice of pie right there. Fantastic. So how do we find the area of this sector? It's just like arc length. Remember arc length? It's the exact same formula. We take that measure of that central angle, divide it by 360, times it, but I don't want the, remember before I was doing the arc length from here to here, I used circumference. Now I want all of this. I want the area, so what am I going to use? That's right, area formula. We're going to use pi r squared. So it's actually the same exact thing as an arc length, but change it from circumference to area. So hopefully this isn't too bad. Let's try a couple. So first things first, could you draw one? Sure, I could draw this. Let's see. So I've got a circle. Whoa, hopefully yours looks a little bit nicer than mine. 6 foot radius, so it's going to look something like this is 6. And then 105, just estimate it straight up would be 90. So something like that would be 105. So it's a 105 degree arc, or it's a 105 degree central angle. I'm trying to find the area of this sector or this piece of pie in here. So how do I go about doing it? No worries. I'm looking at 105 degrees of a total 360 degrees. And what am I going to times that by? Pi r squared. So I've got this right here. And again, this is saying approximate, so I want the decimal, so I'm just going to go straight to the calculator. It is 105 divided by 360 times it by pi. I'm going to use 3.14. Feel free to use the pi button if you want. And I'm going to times it by 6 squared, which is 36. Boom, there it is, 32.97. So the area of this is going to be 32.97 feet squared. So I'm talking area. Awesome. So that's a sector. That's how much of the entire circle. It's not the whole circle. It's just 105 out of 360. It's part of the circle. What if I give you the picture? So it didn't really show up. I think on your notes it may show up a little bit better here. But this is the whole circle. So the line didn't show up. I just want this piece of it. Just this white portion right here, that sector. But this time I want it in exact. Can we do it in the exact? Sure. I'm saying it's 60 is my angle out of 360. Times that by pi r squared. My radius is 12. So there's my area of the sector. And then you just got to reduce it. How many times does 60 go into 360? It's 1/6. This is 1/6 of the circle. So if I drew them, how many pieces of pie would there be? There would actually be 6 pieces of pie. That's 1/6 of them. Love fractions. I could do fractions all day long. 12 squared is 144. And then we got to say, does this work out? This is really 144/6 times pi. So you can multiply in any order. It's all multiplication. So I'm going to multiply it out. This should reduce, doesn't it? I hope it reduces. If you want to go calculator, that's fine with me. You could say, does 144 divide by 6? Yes, this one works out even, but you can also math frac it to help you reduce if you want. That is 24 pi. So that is the exact value. 24 pi meters squared would be the perfect. This is a pretty good approximation though, so we're going to kind of do both of these. That's how you find the area of the sector. Awesome, halfway done. Let's move on. Oh, we got another algebra tattoo. Let's see if that one was Mr. Sullivan. Who do you think's tattoo is this? Yeah, apparently not all the algebras were that good at math in the beginning. Permanent. I love it. I love it. All right, let's talk about a segment of a circle. So if we've got a segment of a circle here, how's this any different? What's this shaded region right here? This is a segment. This shaded region right here is the segment. So remember, the sector was like the piece of pie. This is almost like the crust or something. It's not the crust because that'd be the arc length. This is like a little wedge out there. So this is the formal definition, and it's pretty intense here, this definition. You know, part of a circle bounded by an arc and the segment joining its endpoints. So that's the segment of a circle, because we've had a line segment. That's the segment of the circle. This actual line right here, this actual line segment is called a chord, and we're going to do those later on. I think Mr. Kelly's got chords and whatnot when he talks more about circles. So that is the chord. It's the area between the chord and the arc length there. So very cool. So how do you find these? Well, it's just a process. We're going to do what we just did. We're going to find the area of a circle, or sector. You take the area of the sector, and we know that's this. And what are we going to do? We're going to subtract the area of a triangle. We know that's 1/2 base times height. And that's going to equal the area that we want right there, the area of the segment. So if you think about it, what's happening here is this is the whole thing. I'm looking for this chunk of it. So I'm going to find all of it. Then I'm going to subtract this out of it, and I'm going to be left with just this. That's what we want. So you find all of it, subtract out that triangle, and that's what's left. So it's kind of intense. Let's do one with numbers. And maybe it'd be helpful to see, because this is right here. There is our sector. You're going to find all of the sector, subtract out that little white triangle, and be left with the shaded region. So that's the whole idea. Let's do one with real numbers so you can get an idea of what it looks like. Another tattoo. You know, I said I'm the only one without a tattoo. If I had a tattoo, I'd go for the glory, especially. This is pretty cool. Lots of math in there, ellipses, circles, arc lengths. Yeah, big time. Wow, that's intense. Let's do this one. This is approximate. So I want to find the area of this segment. So I'm looking for the area of the segment. So I even wrote the formula up here. I'm going to find the area of the sector. So I'm looking for this piece of pie right here, right there. It's an 8. It's got that 60-degree angle in it. So just find the area of that. It's going to be 60 over 360 times pi r squared. And then after I do that, what am I going to do? I'm going to find the other triangle. Let's simplify this first. It says approximate, so I can go straight to the calculator here. So I'm going to do this approximate. So I'm going to say 60 divided by 360 times it by 3.14. That's what I'm using for pi. Times it by 64, or 8 squared. And you get 33.49. So 33.49. And again, I had to round a little bit there. So that's the approximate value of the entire sector. That is this piece of pie right here. Now let's change colors. I'm looking at just the triangle. So I'm looking at just this triangle. So it's an 8 by 8 because the radius is the same, and 60. Now it goes back to regular polygons. Or I'm sorry, kind of like that when we're trying to find the apothem and stuff. When you got these little triangles in here, can you find the missing parts? Because what is the base? Well, we got to draw it in there. You know, we got to do something like this. Draw in the altitude. And now I got to find this top part. Well, when I did that, it split it, yeah? 60 and 60 turns into 30 and 30. So really I'm looking at what? I have, this is 30. I'm looking for x, and this is 8. So I want to find the height here. I want to find the height in the other side, because this is the base times the height. So how am I going to do this? I'm going to use trig functions. Definitely going to use trig functions because it's approximate. So what am I going to do? Let's start with finding the x. If I want to find x, it's going to be what? It's going to be the sine of 30 equals x over 8. What if I want to find h? It's going to be the adjacent, right? So it's going to be cosine 30 equals h over x. So, so adjacent over hypotenuse. So let's power through and solve these. So again, I'm going to double check my mode. Am I in the right mode? I am. I'm in degrees, so I'm cool there. And I'm going to solve this. So what was the number here? 8. So it's on the bottom. I'm going to times both sides by 8 to start. So I want to get rid of that 8 in the bottom. I'm going to just do this so they cancel. Same thing for this one here. I'm going to times both of them by 8. So hopefully we're going to get x equals and h equals. And maybe you know it because you recognize this is a special triangle. But if not, no worries. 8 times the sine of 30. Aha, it is 4. And what is the 8 times cosine of 30? Should be 4 radical 3, which is 6.928. So we've got 6.9, let me round it to 3. This I knew was 4, and maybe you recognized it as a special triangle with the whole 1 to radical 3. Awesome, very good. So I have this, so I need the area. So what is the base of this triangle? Well, the base of the triangle would be this whole side here. This is the base. this is the height right here. So the height I know is 4, so I'm good there. I'm sorry, no, the x is 4, so this is 4. So if this is 4 from here to here, what is it from here to here? This is also 4. And then my middle side was that 4 radical 3, which is 6.93. So I've got this as 6.93. So I'm going to subtract 1/2. The base was 8. 4 and 4 is 8. The height was 6.93. And when you're doing this, if you notice, what is half of 8? Well, you're back to 4. So really, I could have just used this triangle here. However you come up with it is cool. So there are some little shortcuts in there. So I'm going to say 1/2, or 0.5, times 8, times 6.93. Hit enter. And I get 27.72. So I'm going to look at 27.72. So I'm subtracting them. This was the area of the whole slice of pizza. This is the area of that white triangle in there. It's going to leave me just that little crust on the edge, just that little nub there on the edge. So let's go ahead and subtract that out. We've got 33.49 minus the answer 27.72. Love it. 5.77. So there's my final answer, 5.77. What is this? This is an area, so we got to make sure we label it centimeters squared. So that is just the area of that little shaded region right there. Fantastic. So it's kind of combining it all together and for one big final problem. I love it. Love it. Last slide here. What do we got here? Well, we've got a cool tattoo. I just picked this one up. If you're going to get a tattoo, might as well make a math one worthwhile. You know, I can't imagine your teacher says you can't use your arm on the test. Quadratic formula is a good one. This guy, he also did quadratic formula, but I don't know if you're going to be able to use it on test. Maybe the person behind you. Maybe he was really good friends with somebody who's sitting behind him in class who wants to look at it. I like this dude right here, too. He's got a formula on his arm. I imagine his right arm is circumference. You know, here's area. His guns. He's got area and circumference. I don't know. If you're thinking about tattoo, maybe think about math tattoo. They're real hot right now, the very end. So, last problem. I want to do this one in exact value. Now, I'm not going to make you do this on the mastery check or even on the test, but I want you to see it, that you can do exact values of this. And it's not too bad. So, it's one more of these. I'm finding this shaded region here. So, I'm going to start off with looking at the sector. So I'm looking at that slice of pizza. So again, what is this? Well, it's 90. It's written in there. There's 90. So I'm looking at 90 out of 360. Times that by pi r squared. So we've got 4 squared. But I want to leave this in exact. So what is 90? Well, yeah, 90 is 1/4 of the circle. I cut that into 4. It's 1/4 of the circle times 16 pi. And again, I'm multiplying so I can put in any order. 1/4 of 16 is 4. So now check that out. That I didn't make it a decimal. The exact value of this slice of pie is 4 pi. So this that's the area of the sector. Then what am I going to do? I'm going to find the exact value of this triangle. So think of this triangle. It's a right triangle. Holy cow, that's a little bit rough. It's a right triangle, so it's 4 by 4. They're both radiuses, or radii, sorry. So it's that. And check that out. This is great. This is the base and the height, isn't it? There's the right angle, so I'm already there. It's just 1/2. Oh, I should put it up here. Minus 1/2. Base is 4. Height is 4, so that's 1/2 of 16. Well, we can write out 1/2 of 16, which gives me what? 8. So what is the exact value of this? This is 4 pi minus 8. I can't combine them. They're not like terms. But this is a real area. This could happen. SAT may throw something weird at you like this. It's 4 pi minus 8 meters squared. So I'm not going to make you do a test, but I want you to be aware that it could happen. Don't freak out if you see it. That is a perfectly fine answer. But a really good approximation of this, if we're doing it and you want to go decimals, would be 4 times pi minus 8 is 4.56. So I would definitely accept 4.56 meters squared. That's really a very good approximation of it, but that would be the exact value. And again, what are we finding? Woo! We're finding this right here. Excellent. All right, that's it. So that's the end of the chapter. I hope this master check goes well for you. We've been kind of in it with the best of. We had the best ping pong, best air guitar, best human beatbox. We're in it with the best optical illusion dance I've ever seen in my entire life. At least top 5. Good luck. Peace out.